Assalamu alaikum wa rahmatullah. In today's class I'm going to talk about the rapid spanning tree protocol, which is the improved version of the spanning tree protocol that we have taken before. So in this presentation slides, actually we have some objectives. So upon completion of this section, you will be able to describe the characteristics associated with the RSTP, and also you'll be able to configure RSTP parameters. So this topic is very simple compared to the previous one because the idea is already taken during the STB, but here we are going to see what is the differences. Okay. Doesn't work. Anyway, here we are coming to the what they call it the STB weaknesses. Actually, STB is very slow, and it suffers from the long time to do the conversions. So during the long convergence period of the STB, the network will stay or will remain in inconsistency mode. So maybe we will lose connectivity between some parts of the network. So that's why we came to the RSTP. So here I want to read this comments. STB ensures a low-free network, but has a slow network topology convergence speed, leading to service deterioration. If the network topology changes frequently, the connections on the STB-capable network are frequently torn down, causing regular service interruption. RSTP employs a proposal and agreement process. So this is one of the differences between the RSTP and the STB. So RSTP implements or employs something called proposal and agreement process. This process will allow for intermediate negotiation of links to take place, effectively removing the time taken for convergence-based timers to expire before spanning tree convergence can occur. The proposal and agreement process tends to follow a cascading effect from the point of the root bridge through the switching network, as each downstream switch begins to learn of the true root bridges and the path via which the root bridge can be reached. So instead of taking in the STB, taking the long path from here to here to get the notification done, and after that we get the conversions done, it will take a very long time. But here in the RSTB, so every intermediate switches can do some kind of negotiation to overcome the long period of convergence process. So here the convergence timer is from 30 to 50 seconds. Here it's based on the proposal and agreement, which is an immediate negotiation. So here the protocol will become faster convergence, and it will reduce the interruptions of the connectivity. Okay. So this is the first difference between RSTP and STB, which is the proposal and defense process. The second thing actually is the RSTP port rules. So in the STB port rules, as you can remember, we have designated port rule, and we have root port rule, and we have alternate port rule. But in here, we have two extra port rules. The first one is the backup. So a backup path to downstream nodes where redundant links exist on the same LAN segment as the designated port. This one is backup. So this backup can be used when we have redundancy between an STB or RSTB switch and non-RSTB switch. So this can be used to enable to make this link active and the other link inactive as a backup, because the other side, this side, is not supporting STB or RSTB. That's why we cannot use the A port rule. That's why they designed the B port rule, which is the backup port rule for non-STB speaking switches to be able to run some kind of link redundancy. The other one is the alternate path to the root bridge that differs from the path provided by the root port of the switch. So this alternate actually is similar to exactly the same as the one proposed in the STB. So the only new port rule is the backup. Okay, and after that we have another thing called edge port. Edge port actually is a port that's connected to the to an normal what they call it system or in system, like computer, whatever, or maybe connected to router or whatever. Anything that's connected to a non STB switch, it should be set to edge port. So systems that don't participate in the RSTB, so here is the definition when we need to use the edge port. When we have systems that that's not participating in the RSTB election, so in this case we set this port as edge port. So systems that does not participate in the RSTB connect to edge ports. Edge ports don't receive BBDU and can instantly forward data. So this kind of ports will be set to the forwarding mode, but it's not going to receive any BBDU. So this is the third difference between the RSTB and STB. So the first difference is the proposal and agreement negotiation, and the second one is the backup port, which is used when we need to run port aggregation between an STB switch and non-STB device. Also the edge port, which is used only when we want to connect a non-RSTB device that's not participating in the STB election. Okay. Also, the fourth difference between the STB and RSTB, here is the STB and here is the RSTB, and this is the port rule. So in the STB, we have disabled blocking, listening, learning, forwarding. But in the RSTB, instead of these 5 states, we have only 3 states. So disabled is discarding here. Blocking also discarding. Listening also discarding. And learning is learning, forwarding is forwarding. So here is the main difference between STB and RSTB. So port rule here, if the port is disabled, it will be in the discarding mode in the RSTB and disable mode in the STB. If alternate or backup, so here it will be discarding, but here will be blocking. If the port rule is root or designated, it will be in the RSTB, it will be discarding, but in the STB, it will be listening. If root or designated, it can be in the learning mode, and also here in the learning mode, and also it can be in the forwarding mode in both versions of the STB. So this is the difference number 4. Here is the RST BBDU. RST BBDU means the BBDU of the RSTB protocol. So unused fields of the STB BBDU are active within RSTB. So some unused fields last time in the STB have been used with the RSTB. So here we have, for example, we have the port rule. 00 is unknown. 01 means alternate or backup port. 10 means root port. 11 means designated. And here we have the TCA. This is from the beginning, from the last version. Also, STB has the TCA and the TC, but it doesn't have the agreement and also doesn't have the proposal. It may have the forwarding, learning, and port rule, but this agreement and proposal are not here. That's why it's some unused fields in the STB have been used in the RSTB. So new capabilities are introduced as part of the RSTB. So capabilities like reducing or making the convergence time faster, and also it has some changes like the only 3 states of the port rules and so on. So here the RST BBDU designated switches generate their own BBDU at hello time, exactly similar to the STB, regardless of whether an RSTB BBDU has been received. So here, this one, all BBDU will generate their own, all switches will generate their own BBDU at hello timer, regardless of whether an RSTB BBDU has been received. So it's no matter if the RST BBDU is received or not, every switch will generate its own BBDU to be sent to the downstream. All RSTB enabled. Maybe here we have something missed. Okay, let us read here to show you a better difference between STB and RSTB. So in STB, after the topology becomes stable, the root bridge sends configuration BBDU at the interval set by the hello timer. A non-root bridge does not send configuration BBDU until it receives configuration BBDU sent from the upstream devices. So this is what happens in the STB. So in the STB, if let's say this one is the root bridge, when the packet is sent here, the BBDU packet sent here to switch C, then switch C can generate packet based on the previous one. So this one cannot be generated unless we receive the packet, BBDU packet from the root bridge. But in the RSTB, every switch can generate its own BBDU, even if the original BBDU from the root bridge is not received yet. Okay, so this will make the time shorter than in STB. So in RSTB here, after the topology becomes stable, a non-root bridge sends configuration BBDU at hello intervals, regardless of whether it has received the configuration BBDU sent from the root bridge. Such operations are implemented on each device independently. So that's why every switch here in the RSTB is going to send the configuration BBDU to the downstream devices, no matter this switch receives the configuration BBDU from the root bridge or not. Here, RSTP conversions. RSTP conversions in all RSTP enabled switches begin as root and send RSTP BBDU. So exactly similar to the STB at the startup time, all switches will consider themselves as roots. Then they exchange the RSTP BBDU, and based on comparing the information of the multiple BBDUs, they can find which one is the root bridge. So ports are set to a designated rule and discarding state. So because every switch will consider itself root bridge, so all ports, as you can see here, are set to designated ports. So the here, okay, it's the same thing as I explained. Just now, nothing new to read. So the RST BBDU proposal, actually, proposals are sent in RST BBDU during root election. So proposals are going to be sent during the election. So if you go back here, during the election, they are going to, switches are going to send this kind of BBDU. So this BBDU will carry the proposal as a field here. So even during the election, the proposal actually is going to be sent to all neighboring switches. So a switch will ignore a proposal if it has a better bridge ID. So if, let's say, switch C proposes to be the root bridge to switch A, but when the BBDU is sent to switch A found that its own ID is higher than the ID of switch C, so that that proposal is going to be ignored. Actually, this behavior reduces the election time. So the election time in the RSB is faster than the election time in the STB, because in the STB, the election actually of the root bridge is going to wait until all switches BBDUs arrive at all switches. So after they exchange among each other, they finally they can decide which one is the root bridge. But using this proposal and agreement, the election actually is going to be done in parallel. So every branch can work separately. So concurrently, every branch will do like internal election. Then the highest priority of the branch will compare its own ID to the root bridge. Okay, RSTP synchronization process. Upon receiving a superior PBDU, switch B will cease to send RST PBDU. Okay, here if upon receiving a superior BBDU, switch B is this one, actually is going to stop sending RST BBDU containing proposals, because they know that their own ID is not the highest ID. There's other IDs better than theirs, better than the ID of switch B. That's why switch B will stop sending proposals. So this will help to make the election faster. Okay, here, since timers don't play a role in much of the RSTP topology convergence process as found within STB, it's important that the potential of switching loops during port rule negotiation be restricted. So this is managed by the implementation of synchronization process that determines that the following the receipt of a superior BBDU containing the proposal bit. So the receiving switch must set all downstream designated ports to discarding as part of the synchronization process, where the downstream port is alternate port or an each port. However, the status of the port rule remains unchanged. The example demonstrates the temporary transition of designated port on the downstream LAN segment to discarding state. So therefore blocking any frame forwarding during the upstream proposal and agreement process. So the synchronization here is only to solve the issue of avoiding the use of timers. Okay. Here, RST-BBDU agreement. So as we remember, we have the proposal here, and now we have the agreement. So once all downstream non-each designated ports have been blocked, switch B here, so all the ports have been blocked, switch B will send an agreement with the RST BBDU. So this is the agreement here. So this switch will send an agreement to switch A to tell the switch A that, okay, I agree that you are going to be the root bridge. Okay, as you can see here, we have failure. So the failure happened here. Let us read the scenario here. The confirmed transition of downstream designated port to a discarding state allows for an RST-BBDU to be sent in response to the proposal sent by the upstream switch. So the agreement actually sent from switch B to switch A is a response to the proposal that's already sent from switch A to switch B. So during this stage, the port rule of the interface has been determined to be the root port. So this port is going to be changed directly to root port rule. And therefore, the agreement flag and port rule of root are set in the flags field of the RST-BBDU that is returned in response to the proposal. So this is how it works. After that, here, we have something called RSTD Conversion Link, RSTP Conversion Link. So the downstream part is again unblocked, and a new round of synchronization occurs between switch B and C. So if this one is returned back to normal situation, then a new synchronization process will occur between the switch B and C. So here, during the final stage of the proposal and agreement process, the RST-BBDU containing the agreement bit is received by the upstream switch, allowing the designated board to transit immediately from discarding state to forwarding state. So this one at the last slide, it was set to the discarding mode, and now it will become set to forwarding mode because it's already changed to D. So here, following this downstream, LAN segments will begin to negotiate the port rules of the interfaces using the same proposal and agreement process. So the proposal and agreement process will be used here between the switch B and switch C, exactly in a similar manner when we use it here between switch A and switch B. Okay, link root failure. So here they put the link and the root together. The failure, they consider the link failure and the root failure is similar to each other, while in the STB, each one creates different scenario. So loss of upstream RSTP BDU signals link device failure. The proposal and agreement-based convergence will ensure. So if let's say the upstream BBDU is lost, that will determine a link or device failure. So the proposal, after that proposal and agreement process is going to be ensured. So it will start directly the proposal and agreement process. So in the STB, a device has to wait a maximum age period before determining a negotiation failure. In RSTB, if a port does not receive configuration BBDUs sent from the upstream devices for 3 consecutive hello intervals, the communication between local device and its pair fails, causing the proposal and agreement process to be initialized in order to discover the port rules for the LAN segment. Guys, these things actually, we has nothing to do with that, but in order to understand the behavior of the protocol itself, we have to go through all of these scenarios. Otherwise, we will not be able to understand how to fix, how to troubleshoot if in case of any failure or in case of any overhead. So here, all of these cases, scenarios, and so on is not going to be related to the configuration, but it will allow you or will let you know why you need to do that configuration or when you need to use some configurations. Okay, topology change process. So the first one here, link route failure. This one is if the failure happens at the upstream. But if the failure happens at the downstream, so during the sending of an agreement, addresses are flushed for all ports except the port on which the RST BBDU was received. So in this case here, during the sending of agreement and all of the MAC addresses will be exchanged between the switches, between the switch and the other neighboring switches. But in the previous STB protocol, they have to wait for 300 seconds in order to update. That's why it's this one RSTB is much faster than the STB. Here, STP Interior Operation or Interoperation. RSTB switch ports will refer to STB when connected to a LAN segment containing an STB-enabled devices. So if let's say we have RSTB device here, for example, switch A and switch B are both of them are STB enabled, RSTB enabled. But this one is only STB. This one can support only STB. So in order to work together, switch A and switch B, they have to downgrade themselves by enabling the STB mode. So this is how they can fix, because this one cannot upgrade to the RSTB. So switch A and switch B, they have to downgrade themselves to STB to be able to communicate with the switch C. Then here, setting the mode. Setting the mode is exactly the same as the STB. So we will still use the STB mode. Then after that, we will decide. We will select which version, the one that we need to run. So STB space mode space RSTB is to enable the RSTB mode of the switch. So the STB mode RSTB command allows all ports of the switch to generate RST BBDUs. Here is the configuration validation. So if you want to display the STB, you can use display STB and you can see all of this information. So here you can see STB conversions mode is normal, TC or TCN received, how many TC or TCN received here, and TC count per hello, and many other information that can be helpful in case of troubleshooting. So here we have the setting, how to setting the edge port. So if let's say at the switch C we have port number 3 is connected to an end system or an BC. So in this case we have to go to the interface 3, then we have to use the command STP space edged port, edged dash port space enable. So this command allows for transition of the edge port to forwarding without delay. So this port is directly will be set to the forwarding mode, and it's not going to receive any BBDU packets. So interfaces on the S5700 are non-edge ports by default. So all of the ports by default are non-edge ports. So we have to take care of them in case we want to use this kind of configuration. So setting the each port here, so all ports on the switch will be configured as edge port. If let's say we use a switch without maybe a standalone switch to be connected to BCs, so in this case we easily run this command STB space edged port space default to change the mode of all ports to edged port. So care should be taken with this command to avoid STB loops. If let's say we use this edged port default command with all switches like now connected to each other, where the redundancy of links are existing. So in this case, this will cause a lot of switching loops. So we, using this command, we could disable the STB or the RSTB functionality. That's why the use of this command must be under very careful control. Okay? Not like this, you just run this command. You have to carefully think about it. You have to carefully calculate every possible scenario before you use or enable the edged port by default for certain switches. BBDU protection here. Here we have something called BBDU protection to prevent the malicious injection of BBDU into the RSTP. So this is exactly similar to the BBDU protection similar to the root protection in STB. In the STB we have root protection and we have also loop protection. But here we have loop prevention, that one. And here we have something called BBDU protection. So this is going to prevent the malicious injection of BBDUs to the RSTP. Loop protection is similar to the loop protection in the STB. So also the command is the same. So if BBDU fail to be received by the downstream switch, the root port is blocked to prevent switching loops from occurring. So this one is to prevent the loop from happening in case of losing the BBDU from the from the upstream. Okay, here is the validation of the configuration. You can use the display STB interface gigabit Ethernet 001 is to display the STB configuration for the certain interface. So it would show you the port of the protocol is enabled. Then the port rule is root port. Port priority is 128. Port cost is 20,000 set by default. And here designated bridge port is this, and port edge is this, disabled, and point to point is auto and true. Also transit limit is 147 packets, hello time, and protection type is loop, because protection type here we have BBDO protection, we have loop protection, we have also root protection. Port STB mode is the RSTB. The mode of the STB is set to RSTB here. And also port protocol type is .1s by default or automatically. Then the BBDO encapsulation is configured to be STB. That's all about the RSTP. So I hope everything is clear. If you have any unclear things or any missed information, you can contact me, and inshallah I'm going to explain, and I will do my best to help you. Also next lab, inshallah, we are going to configure the STB and the RSTP using the simulator together, inshallah. Okay, see you inshallah next class, and have a nice day.